um, Good evening. Okay, so finally you're connected. I don't know if we will be waiting for others, but I suppose the time is not super. We don't have super long time, so maybe we can already start the class, right? Yeah. Okay. I will share the Windows system like I do all the time. Yeah. Okay, so Windows system is being shared. Um, Let me check the sound. Yeah, so sound is being activated. Uh, Good evening, Edwardus. All right, and then maybe let's overlook material, which is not the Python based, but well, because we have like only one class, so at least we can overlook thing which is super popular nowadays, especially within the Python. But the problematic of the topic is that most of the people just try to use some libraries which implement things, but they have no idea how it works. Um, Oh, I see that Windows system is being paused. Okay, let me activate this. All right. Um, so maybe let's take a look on that topic. So I uploaded material, and you already have it. The only thing I cannot really reformat the presentation. Um, so this presentation will be in the scheme of how to say my so-called home institution. But actually, it doesn't really matter. Okay, a computer vision. Maybe you have heard something about this topic, or maybe you even used something related to this. What would you say, guys?
Это что-то, то, что, например, определяет объекты какие-то, да? Например,
Это может распознать начертанный символ. Это может быть распознавание там лица, допустим, каких-то условных линий объектов. Да. Okay, well. I guess it could be that that might be none of you tried to do something like this, especially from the scratch. But let's try to talk about this topic in the way of introduction into this. Trying to get how these things are working, and maybe in the end we will try to implement at least super simplified system. Well, let's see if we will have enough time. I don't really think so, but let's try. So things related to computer vision, they are actually everywhere. And the thing is that if we don't see something, it doesn't mean that things are not that there is nothing. So, for example, we always under surveillance cameras when we okay, maybe not in our homes, but when we go somewhere outside, well, cameras are everywhere, and cameras are filming us, and literally why they're everywhere and what's the reason. So looking at the pictures which is received from the cameras, it's possible to say that if you were on the on that recording, or maybe not you. And if we can just visually recognize something in the similar manner, it's possible to recognize by some algorithm, because if we can do something, we can actually formalize the method, how it happens. We can analyze what processes are happening, and we literally can create our own artificial methods for this. And here I listed several fields which are used daily, and we don't even think of these things. So car number plate recognition, the barcode recognition, and the story is not about those barcode scanners. The story is about whatever, or let's call it customized barcodes and labels on the warehouses when it's impossible for human even to read what's there. But computer can do that actually. Next, the blind man's problem, like a recognition of the text. So you know the devices which allow books to be read for blind people. Automatic filtering of printed documents. Well, again, labels on the warehouse, but a bit different way. Registration of railway wagons, which is implemented almost everywhere on every station. And ATM cash recipient system, which literally analyzes well if you pulled banknotes inside. And those are only 7 points from a super big list we cannot even list in one slide, which is, I suppose, quite understandable. Oh, and for sure we can list here mobile phones, so maybe banking applications that literally don't ask you for a password. The camera should just take a look that it's you. So it opens banking system on the mobile phone, for example, and tons of other examples. But what they are based on and how it happens, that recognition is possible. Um, well, here we have a lot of text. Honestly, saying this presentation is just based on my bachelor thesis. So there will be a lot of information. So maybe I will just highlight the most necessary things. Literally, if we try to overlook and understand how method works, we always have to take a look on how theoretically things are possible to be done. Which equations allows us to make sure that method works? Like if there is some evaluational results. Like on the percentage of this, we can say this, on the percentage of that, we can say that. And surely we can think of whatever method, how to say enhancements, and so on and so on. Literally, today I'm going to show you maybe two methods, which are kind of super basic ones. Real applications, they use these approaches, but as only like maybe 10 or 15% of the overall solution. But I think it would be interesting to get things. So now we'll be talking about symbol recognition. When we have a picture of symbol, an application would try to guess what is written there. And we will take a look on two methods: pattern recognition and recognition by neural network. Have you ever heard something about the pattern recognition?
It's like scanning a QR code. No?
No, not at all. Not at all. Well, the method actually is hidden inside its name. So you have some patterns. So you literally have something you compare a received data with, right? That comes from the name. And as well as for the neural network, well, we need to know what the neural network is actually. Okay. Well, let's overlook the pattern recognition firstly. So if we think about the algorithm which is about to be run on a computer, right? So whichever thing which is optical can be shown in a picture. Even whatever symbol which we make a photo from will be represented as the image on the computer. So that means that that image will have its size in pixels, and there might be some fractions of colors which should be filtered. But anyways, we will make an assumption that filtering colors and correcting colors is not the problem which is solvable by the method itself. So we will make an assumption that we have only two colors, the background and the symbol's color. And the idea is that let's say we have a picture of a symbol like this one. So what do we see here? Well, we see a border of the image, which is the gray. That just limits area which we can work with. We have white background and we have black foreground, or in other words, symbols pixels. And as you understand, here we have pretty enlarged image. What makes us clear that this image is being enlarged? What would you say?
Pixels?
Yeah, but if more specifically, then it's pixelization, right? So the image itself is kind of drawn in a so-called Minecraft style, right? When we see literally cubes. Well, originally this image is much smaller. The only when we stretch the image itself, it becomes that there is the area which has been assumed as the cube. But the thing is that it's just an artifact of stretching the image. Or there could be another case when exactly each cube of the image was originally a pixel, for example, or maybe square of 4 pixels. That could be possible as well. So as we understand right now, by having the enlarged image, it's impossible really to say what was how the original image looked like, because this one is just a modified image because it was stretched. That makes sense, right?
Yes.
Okay. So the pattern recognition by itself literally assumes that you have a picture which has the symbol you would need to recognize, and you have a set of symbol pictures which you're gonna compare with that one which is received. And surely the comparison by default or without any enhancements of the method happens a pixel by a pixel. Frankly saying, that means that you have to have a pretty large library of such images, and you have to store them for every font and for every size. As you understand, it's not a problem to store this data, although that would need enormous amount of space on the hard drives. But the main problematic is not the space on the hard drives, because nowadays we can buy terabyte drives, and it's not a problem. For example, only on my home computer I have 14 terabytes, and which is not enough actually. Yeah, so so the space is not a problem. The problem is that that data has to be analyzed, and we have to go them through to find out if the current image is close enough to the given one to say that, well, most likely there is drawn the same as we have on our template image. And to make it possible to make such conclusion, we have to have an equation which is shown here. So we take into consideration symbols, pixels of the corresponding in XY indexes or positions from both of the images, and if they're the same, so we literally see, okay, we found out the pixel which is the same for each image, so we have to collect them, and we literally have to divide them with literally amount of all of the pixels. Or we can even make it even a bit different. We can divide that number with, or just multiply if you like, to make the algorithm more not really more correct, but more sensitive to amount of data. Then we would multiply that with amount of pixels for symbols only. But again, this method is kind of good or bad. Sometimes it works better, sometimes it works worse. But anyways, we need to go through enormous amount of templates. And literally that means this approach is not really useful in aspect of the time consuming. So surely it has the strong side. So if you found out 100% comparison between given picture and from the template, then you can 100% let's say, even especially when the method is sensitive, so use only symbols related to pixels, then you can 100% say that you found out what was drawn there. But on the other side, the weaknesses are related to enormous time consuming for going through all of the images and going a pixel by a pixel, which actually is the critical point for this method. So how we can modify this method? Well, we have to think of on the critical points, like what would make an influence of the template library size, what will be the comparison, how to make the comparison speed faster, and so on and so on. Well, what can we do? Well, maybe I will show you just the solution. Well, we can think on some areas which are gonna be used for comparison. For example, we can make a split of the image into a certain amount of regions, maybe 8 by 8 or maybe 16 by 16, and then you can just calculate the value of the region somehow, and then you can compare only regions, and that would literally make it possible to store the template only of the biggest size of the image and of the symbols image, and that's it. The other question is what that region literally represents. And such region literally represents a so-called two-dimensional density, and that's actually the most simple variation of this method. So, for example, if we will take a look on the left image where we have smaller image, so we have 1 pixel of a region. So literally two-dimensional density of that area will be 1 or 100%. On the right side, we have a bigger symbol, and it has already 4 pixels. So in this case, we say, okay, we need to count how many of those pixels have a color of a symbol, or in other words, how many of them are black. So we found out 4. Okay, so we make the dimensional density for that area 4 divided by 4 multiplied with 100%. So it's 100%. So the area has a density, two-dimensional density of 100%. So literally those 100% and 100%, they can be compared between themselves. So that becomes the area of comparison. So not a pixel anymore, but something that would represent the area. Literally idea here is very simple. Why such a split in areas works? If we will try to get symbols of different sizes, and we will try to measure parameters of the symbol with their sizes in different equations, you will find out that for every symbol, the proportion which you will be looking for will be more or less the same for every of the sizes. For example, having sizes from 8 to 72, you will get the same values. Maybe I have it here. Yes. For example, it's here. Height divided by size, and here I used the uppercase W letter, just as an example for all of these slides. So you can see approximately ratio will be the same for every size. I suppose you can say this. Nextly, width divided with the size. Again, approximately it's the same. Amount of symbols of symbol divided by square of the size. Again, you can see that value is approximately the same. Similarly, if that would be an amount of pixels, which is not actually the story related, but anyways, even this parameter will be plus minus the same. And only in the cases when we have super small size of the symbol, it will be just hardly to calculate such values accurately. That's why here we have kind of varieties of the values, but still plus minus is the same. Two-dimensional density of the whole image. Again, you can see of the whole image of the symbol for sure, and you can see even this is the same, well, almost the same for every of the sizes. You can see this, right? I really hope you get these things, right?
I mean, yeah.
So on the left side we have size, on the right side we have a parameters value. Yeah, so actually that makes it possible to work on comparison. And what do we receive in the end? So you can call those sectors maybe as elements of two-dimensional matrix, and in the end you will be getting two-dimensional matrices for every symbol, which comes from the library and which comes literally from the drawn image, and then you compare them. And based on this comparison, you receive the result. And in this case, we have 16 on 16 elements, so that would be the same as you would have symbols written only by the size of 16 pixels on 16 pixels. As you understand, that would be quite small image of the symbol. But just keep in mind that that in the same time you would need to work with super large ones. So you can think at least potentially how many times we increase the speed of the method only introducing another comparison array. Makes sense, right?
Yeah.
Okay. Yeah, and what happens then? Then we just say that some of the symbols is close to the drawn one on the percentage level. So yeah, we have even screenshots of the application. Afterwards, I will show you that application. So literally we can draw symbols and we can literally see results. Okay, maybe it's the time for showing this. Well, actually I did that application long time ago when I was well, the first version was when I was on the bachelor's. Actually, that's kind of my so-called second variant of the bachelor thesis, through which I created that two-dimensional things and other stuff. Then it was published, and people use that already for their own implementations. Okay, where do yes, so it's in the library. Yeah, in my library. And I have tons of different things here, and it's gonna be OCR, and well, I don't know. Here I have lots of versions. Yeah, this one was made a long time ago, like in 2010. But this is a bit more advanced version of the application, not exactly that one. For example, we can make patterns, we can draw something, what we would like, and we can just analyze. And you can see there is the percentage of the comparison. So we literally can do a lot of a lot of different comparisons, right? And you can see we will be receiving the result. For sure, guys, such comparisons assumes different fonts, which are gonna be used for the library, which frankly saying will be quite a quite good case, because sometimes you could have like several symbols, right? Like here. And what we could do, well, we could just find out not only the symbol itself, but even approximate font, which is being used for a symbol. Surely such calculations, they need some more algorithmic things, because actually the method can be wrong at some of the cases. Like you can see, for example, O and a 0, that in most of the cases can be just not correctly recognized if it's O or 0, or sometimes 1 is being assumed as 4, and some other small problematics. But I suppose overall idea could be understandable, isn't it?
Yes.
Mm-hmm. All right. Okay, so I switched to the chat. Is the result always correct? The thing is that if you have, let's suppose, a symbol, or let's say different symbols but written let's say different symbols but written in the same manner, then a result could be not correct. Yeah. So if you have pretty close symbols, they can be recognized incorrectly. But it is good because even you can mix up a 0 and O, right? And for example, if we will take this case of this one, I will open this again. So this one, if I would say that here you have the letter, most likely you will think that the letter was not finished. And that could be a part of the letter. So it's not one, it's just a part of the letter. Because actually, even we can make mistakes in this. Which Frank is saying is the normal case. All right. So let's maybe take a look on another method, the method of the neural network. Well, the story itself about neural networks is an interesting thing. So have you heard something about neural networks, guys? Oh my, ChatGPT. Well, GTP, if I'm not mistaken, not GPT. GTP, if I'm not mistaken, text processor. Yeah, general how to text processor. Okay. Oh, yeah, exactly GPT. All right. Let me Google that. Oh, okay. That's strange. Okay. Okay. What's the abbreviation then? Pre-trained transformer. Okay, I was thinking is the text processor. Okay, pre-trained transformer. Okay, makes sense. Makes sense. All right. So, principle is not similar. No. In this case, principle will not be similar. It's based on similar methods, but principle is a bit different. Or I would say that's the certain implementation, certain variation of implementations. All right. So maybe well, I can show you guys this part of presentation for just optical character recognition, or if you like, if you never heard about neural networks, I can show you another presentation, which I show regularly on IT master classes related to artificial intelligence. In that presentation, things are described in more live cases. So would you like to take a look on that presentation maybe? Yeah, why not? Okay, then let's do like this. So we will be then spending time today, well, this evening on understanding how these things works, and then if you will like, well, you can use it then somehow. Oh, well, somehow. Well, I will even show you some examples. All right. So in this case, let me open one of my working libraries. Well, yeah, a list of universities I'm involved in. Okay, so primary, I saved that somewhere here. Let me find this out. Where was it? Ah, yes, here it was. I think I will not launch this presentation. Otherwise, there will be music, some video effects, and I suppose the screen sharing will just eat out some effects anyways. So here we have several sections of the presentation: the neural network, genetic algorithms, and agents, or you can call them NPCs if you like. Because this topic is strictly connected to NPC creation, actually. Well, you can use it in your games as well. So idea is that okay, the neural network. So as I said, there will be a lot of live cases. Yeah, so that's there will be a lot of fancy images. So and I will start this topic like how to say from Adam and Eve. So from far away things. So uh, so all descriptions will be related to things how we think, because actually our thinking processes working in the neural network way, because actually our brain is just enormously complicated neural network, as you know, guys. So so what is the classical example of the work of the neural network? It is conclusion about someone, about something, conclusion about how things should happen, so how they will be happening, how the human being will interact with others, and so on and so on. And in most of the cases, such conclusions, they are based on things we see, things we hear, what do those things mean, and so on and so on. As an example, let's suppose you met someone, right? And your decisions about the person can be pretty different, and your conclusions could be based on what are those processes that person you met would be capable for. Well, maybe in the end that could be maybe marrying the person, killing the person, ignoring the person, and others. But even those final decisions, those are just decisions where you have answers yes to do and no not to do. They, in their order, are based on some other ways how we feel about the person, and think about these feels are related to if we are more for one conclusion, if we are more for another conclusion, and that's based on parameters of the person we see. For example, parameters could be different. Well, there would be a good charisma of the person, and person could be quite talky, for example. So literally, we evaluate both parameters of charisma and talkativeness of the person, and literally, we have our own preferences for every of these parameters. Well, that's why one person talking with someone reacts in one way, and another person talking with the same someone reacts or behaves somehow differently. It's only based on our so-called level of importances for all of the parameters of the person, because the person has parameters which will be shown in the same way for all the rest of the people. So it's just a fact, and the thing how we feel about this parameters, it's make a difference of how we behave for those persons. I suppose this would be quite understandable. Literally we can measure parameters of the person and of something in numbers, because actually if we want to computerize something or digitalize something, we need to work on numbers. So we can measure each of the parameters we see in the person in the range, for example, between 0 and 1, and then we can think of, okay, well, we can like parameters, or we can say, well, we can like the person, but in reality, we like person parameters or a set of those parameters. And literally, there could be a so-called mistaken um, uh, mistaken consideration of what would happen if the person would be, let's say, with more charisma, more talking, more caring, and other things. And we could literally draw the line, or which would literally say if we're feeling in a neutral way for the person, or we are feeling in love, for example. In other words, we like the person. As we know, such strict thinking is not happening in the life, right? Because literally we cannot really measure parameters in numbers accurately, and sometimes the parameter which would literally mean that that someone would be falling in love would be correct for one and wouldn't be correct for others. Literally, that's about parameters themselves. But actually, in real life, even if we are considering the same level of importance for the parameters, um, literally are happening in the way that we are more for one thing than for another thing, and there is kind of the region of parameter value combinations when we are kind of quite unsure if we're more for one or we're more for another one. That's the thing, and we will be using that afterwards. But actually, such real-time thing is based on so-called weighted summations, or in other word, it's called a Weiss neuron. We will be using that afterwards. Okay, so yeah, literally there could be a lot of such parameters, and every of us, we have kind of feelings about, according to the example, about the person based on our level of importance of these different parameters. And we can say that, well, that person could be for someone more as the partner in the work, for someone else, that someone else would consider the same person as, for example, the life partner. Well, why not? Literally, the person itself shows the same sides of let's say herself for everyone, but for one, taking into consideration their own level of importance of parameters. Someone sees the person in one way, another one in another way. So actually, all is based on the levels of importances. All right, and surely every of decision about the person, let's say how person is good according to our own thoughts. If person will be a good life partner, will be good for cooperation, or for together work, will be good for traveling. All this could lead us to another conclusions. For example, if the person is someone we would like to get married to, well, why not? And for sure, this is the case when the answer of the neuron should be strictly yes or strictly no. So that's why here we have this different signs or different ways how the function, mathematical function, can distribute its values, right? I suppose you understand this, because I guess that you know the basic mathematics. But let's talk maybe in numbers. Let's talk more close to digitalizing of these decisions and conclusions. So here we have a small representation of the neuron. Literally, the neuron itself is the function which is gonna be executed. So we have to run the function. We're not talking about which equation is in that function. That's strictly up to developers of the neural network. But we know the ranges of the values which are going to be received as the argument of the function, and we a priori know a ranges of the values which are going to be results of the neuron. Does it make a sense, guys? Yes or no?
Yes?
Mm-hmm. Okay. So the only thing and the only question is how that could be possible if the function which makes conclusions and decisions is connected to different parameters, and we have different level of importances. So in this case, let's call those levels of importances as weights. And let's suppose here we have the case when we have parameters of the same values. Well, let's call them like 1. So every parameter has the value of 1, and our levels of importance is literally say how bigger influence we give to every of these parameters. And for example, if our weights for those parameters are such ones, then the half of the value, the half of the parameter of the neuron function argument will be taken by the second parameter, or by the green one. And the rest will be proportionally split between others. Does this make a sense?
Yeah.
I think this picture represents everything very, very nicely. We don't even need to read the text, I suppose. And then in the end, we can literally calculate the resulting value according to the previous picture, and we can make it that way. So we multiply parameter with the weight plus parameter multiplied with the weight, and so on till we go through all of the parameters will be needed for a function, for the neuron function. And that's it. That's literally the principle. Well, which problems can it solve? So here, for example, is the code which I wrote, well, like maybe 15 years ago, about how to teach the neuron to work in the proper way. So there is such method called the backwards propagation, which is the classical method. Maybe I'm not gonna teach you, but in the previous presentation, which I shared with you through Moodle, you can find out the whole description of this because I wrote there, like my version of that method. So here we have the neuron with randomized weights. An idea of the neuron to give you x1 plus x2 square. So literally we can train the neuron to work in the necessary way or in the way we need. Some of you would say, well, it's better to take the calculator, but let's assume you would need to teach the machine. Or you would need to teach, let's say some I don't know, biological computer of the future which works only on neural networks. Well, on the one side we could say, well, what the hell a story is about? But actually, if you would consider such possibilities, such things, then you would find out that literally you can teach whatever dynamical construction to reach results you need, which is actually a good thing. So here we have a kind of comparison between real result and predicted result. Initially, the real result is the kind of faked, as it's understandable to run the while loop. And then we are randomizing the values. We are finding out predicted calculation. We find out the real result of the neural network. We make how it's been called. I forgot. We make the functions. Well, I forgot this. Well, it's the same like you making derivation. Yes, the derivation of the function. You know derivations, right? Yes or no?
Say again? Derivations?
Derivation of the function.
Well, I don't know.
Okay then. Well, it's like the function of the function which shows how the function value grows while you grow the argument.
Okay.
It's something like for the car when you would need to say what speed will be after some time, and you use acceleration. So acceleration is a derivation of the speed. So literally how speed is being affected in time. Makes sense, right?
Yes.
So the same happens even for mathematical functions, but okay, if you don't know this, okay, let's just pause this, and then we just find out the influence which gonna be made on those weights, and in the end, we train the neuron network, sorry, in this case just a neuron, in a way so that would be making operations which will really need to be done. Surely there is even the case of two neurons, but let's just pass this because you won't get the method if you don't understand the derivation itself. So let's just pass this. And let's maybe go to the next one, genetic algorithms. Well, genetic algorithms is another topic of so-called unclear algebra field, which is related again with data propagation, maybe some mutation of information, and so on and so on. Idea here is very, very simple. We just introduce each of the entities as the part of population, and then what we do, we say that each population entity has the set of its parameters, and amount of parameters is known, but the values of parameters are just based on the previous generations and some mutations which can happen in the end. Surely, if two entities produce the next ones, the next generation entities, then literally their parameters are being mixed up between so-called parent one and parent two entities. Well, the same like happens in the life. So each of us will look similarly to our parents. Well, it's just the principle of this sharing and mixing parameters. Makes sense, right?
Yes.
Yeah, because again, all this literally comes from the life, actually. And the mutation is just a mutation. I suppose here we have nothing to say. What tasks such such methods can work on? Well, the method which I created like around maybe it's already 12 years ago, was related to finding out the trajectories equation based on genetic algorithms. Uh, it was developed for, well, there was one project for cooperation between Latvia and Lithuania. Well, I don't really remember in what field, but I created that time this thing. Literally, idea is that we have on the left a drawn line, and by using genetical algorithms, we can find out parameters of the line function. Here it's the basic parabola. So yeah, literally we need to consider different possible function equations, and for them we can find out parameters. So maybe nothing super interesting for you at this point. But let's talk about how these things can be combined and used in real life. Well, as I said, that could be NPCs, like artificial entities in your games, or maybe not only in the games, depending on what you would like to develop. So what do we have here? Here we will have the case of the following. So we will have agents, which are entities, and we have red items, which are food items. And entities should grab the food and should eat it. and should not to share that food with others, just to guarantee its survival. So idea of the entity would be the following. So oh, and by the way, you see each of those green entities, they have their nose, right? So a small stick connected to them. You see this, right?
Yes.
That literally points to the front direction of the entity, or in other words, or direction of the site. So literally for the entity itself, a conclusion, here you can see small neural network, a conclusion of how fastly it should move right now, and if it needs to be rotated based on the following. On the closest food item, on which angle it's located, which distance, where the closest entity is located, that's related to a distance, and the angle to the sight line of the entity. And all these things, they are being used as input data, the same as parameters of the person in previous slides. And literally, if we have different generations of such entities, then how it happens that newest generations will receive the knowledge of previous generations and will work more effectively than previous generation? Well, in this case, we can use the genetic algorithms approach for storing weights, or as I called them previously, levels of importances of each parameter for the entity. In other words, guys, it means that if something was important for the previous generation, it will be important for a new one. And if something was not important for the previous generation, then for the new one, it will not be important as well. That makes sense, right?
Yeah.
Okay. And then even mutations can happen, but that just affects quite selectively on specific entities of the whole population. And actually, that's the full story about how you can use it. So, would you like to see in actions those entities? Yes or no?
Yeah. Yeah.
Mm-hmm. Okay. So here we have one. You can find out this solution on GitHub, but it's not fully working actually. But you can find this on the GitHub. So here we have a zero population. So they don't have any experience, and they can just randomly catch the food item. Well, we can even make the food item moving. That will literally be generating the cases when suddenly and randomly entity would eat the food and get some knowledge. Okay, I get the food, so maybe I can get the next food item more effectively if I will do some actions. Let's maybe run 100 generations, and let's see how they will start behaving, catching the food items. Okay, here on the bottom I have the progress bar. Let's wait until it will be finished, and once it's finished, the whole evolution of 100 generations will be done. Yeah, so you see, they start catching the food items, and some of them are just standing on the places. You can see, finding out it's not necessary to run for the food. So food will be still accessible for that particular entity. So you can see some of them are more close to the food item, so there is no need to run. That one will not catch the food. Or the food will be still available, so no point to run quickly, like for this one, right? For some time. So literally such methods they can show you yeah. So you have seen how things happen here, right? It was very interesting. So literally each try to make the next evolutions of such agents, they just show a very unique way of the whole generation behavior, because there are mutations introduced in this. And I can say you that sometimes the whole generation can start moving backwards actually as well. And actually each of these entities, they have their own neural network with their own levels of importances, or as they called in literature, weights of parameters. So you can see how this entity is playing with others, right? He's the only one who will get the food. So for him it's not necessary to run for the food item. He will be the only one who will get this. And he knows that. Okay, and some of others, since their opponents, they can find out some other tactics to reach the food of the one who is forwarding them for the food item. Well, you have seen this, that was shown with specific rotations of entities. So, does it look interesting for you guys?
Yeah. It looks fun.
Yeah, it's exactly is the fun, yes. For example, I really keen these things on. Yeah, okay, words can describe how interesting. Is it really so? I mean, Douglas. Ah, sarcasm. Okay, okay. But you know the thing is that maybe for now you cannot really imagine where these things can be used. But as someone who developed different such systems, not just with NPCs, but just with real life object recognitions and understanding of what is happening in front of the camera, I can say you that there are a lot of possible projects which actually everyone can make and just earn money on these things. For example, I personally wrote a lot of applications for warehouses for understanding the old labels and tags. Applications for parking lots, so automatical system can show how many of the parking lots are free or occupied by cars, and so on and so on. All this is usable in life, I would say. And the mostly interesting thing is that you can earn on this. And that's really so. That's really so. Okay. Well, what else I can show you? Um, well, let's take a look. Oh, then okay, maybe OCR. Ah, okay, that's the same OCR as we had, but let's suppose if we would use the neural network for the character recognition, then again we can just draw something, and the neural network can approximately get which character is being written. So as you can see, here I wrote this for in a very unusual and fancy way, as you can see. But still, if the neural network knows digits, then it takes a look on it and says, well, that's more close to the 4. Literally by this the similar neural network as we had here. Okay, the structure is a bit different, but principle is the same of the usage. So literally, again, we can make these things. And for example, will there some symbol which would be written in a such way and recognized by the template? Well, no, I don't really think so. And the result which we would get given this picture to the templated approach would give us problematics in the solution. So result just wouldn't be found out. We can try this. Okay, here unfortunately we have only numbers. I suppose. Okay, let's try to get the biggest border as we can, and let's maybe draw this approximately in the similar manner. Make patterns should be the first thing. Yeah, so something like this. Yeah, so you see, it's 9, but actually it will be recognized incorrectly. and for this thing, okay. Okay. it thinks it's 7. Oh yeah. Because, for example, in this case, this 9 looks more to a 0. Okay, let's receive the memory base. Literally, all of the known symbols, they will be just, used again for teaching purpose, and then we can, we can give another value. Well, let's call this 9, so neural network would know that it's 9. And let's draw this again. Okay, so you see, it's 9. Also, in the same time, we draw something pretty creepy, all right? But in the same time, it's gettable for neural network. Okay, maybe let's return to that initial presentation, which we had. So the only addition which I would like to add here is that the inputs for the input layer of neurons for symbol recognitions would be those. Well, those could be pixels if we give pixels to the neural network, but more correctly is just to create the neural network which receives the same amount of regions, and the value will be a region representing value, again, two-dimensional density, which could be the float value or which could be integer value. That's really up to you guys. So that's the only addition I would like to add to previously overlooked things. Surely here I have a full description of the backwards propagation method as I could describe it. But again, it might be a bit a bit complicated, but you have to know the essence of the function derivations, which is not your case as I understood. So that's why we're just passing this without overlooking. But I think that more or less it's understandable how this is being done, at least on the theoretical level. Is it so, guys?
Yes.
Okay, so here I see the question from Mindaugas, but does it start?
You already answered it by when you started
Okay.
to talking
All
about
right.
it, because I start thinking like, but how does it know when you just made a program? How does it know if it's a 1 or a 2? You still
Yeah,
need.
because you have to give them pre-known knowledge base. So what I did, I created the memory base folder with such values, and as you can see, each of these pictures, they have their symbol and the index of the picture. Like 0 has 5 variations, right? And they're being numbered from 1 to 5. And when I loaded these images and I trained the network by using backwards propagation method, I literally said that the expected result is going to be, for example, for this picture, 5. And if the network gives me something different, I'm just telling the neural network, well, you gave me incorrect result, let's reteach you. And for small neural networks, it happens very, very fastly. So yeah, that's an idea. Okay, do we have any other questions? All right. So if you want to know more about this topic, let me know. I can just recommend you a couple of books about these things. But again, such thing is the one which I would maybe recommend you to try, because again, repeating, as for me, it was one of the fields where I could earn some time ago. Why can't you do this? I don't see any limitations. All right. Well, for sure, we kind of have some minutes left. Okay, so maybe you could add it to the module sooner or later. Could take a look into material. You mean that second presentation, right? Okay, yes, I can put it in the module. Yeah. All right. So I don't even know what to show you more about these things. Maybe I can show you one of applications which was developed some time ago, but I'm not sure if the server will be still supported. Where was it? Here? No, it's the Finnish company. Yes, the Bizet company. Well, we used for this thing such cameras called Mobotics. These are very interesting cameras actually. They are very specific ones, and they have a very interesting interface like this one, because they can catch objects very nicely, and then recognition can be used because the picture itself will be super clear. Yeah. Okay, maybe I can. I don't really remember in which folder things were saved, so maybe I will take a look a bit. Yeah. So such interface. So there were possibilities to use different databases with different ports. With saving information even into files. So we could switch to different databases. Okay, in this case, as you can see, it's not switching. There could be a selection of the image source for different things. Actually, we had actually we could even activate cameras, but I'm not gonna around this. Literally, we could catch images. Okay, I will show you if I have some of the pictures. Wooden cars. No, not this one. Stoyanka video. Okay, what was here? Yeah, just so there was a time when you put two cameras on the car and we were filming the path. Just moving through city just to get if things are really recognizable. Yeah, and literally a lot of different things. Okay, what is here related to a file name? Okay, well. Anyways, a lot of interesting things were done some time ago. What is it? No, it's different. That was the project for cashier machines. Okay, I don't know. Maybe I don't have images about exactly this thing. What was here? Okay, doesn't really matter. Okay, well. Anyways, tons of things are possible to be implemented, as you understand, guys. The only is to try and try again, something like this. Okay, so maybe we can finish then at this point. If you have any other questions, please ask before we will finish. And I got an information, by the way, while you are thinking or writing, that it looks like that the next week, when we will be working on the Python, will be between 11th of December and 17th of December. And it looks like that during that time I will visit. I will make a visit to Utena. So probably I will see you in person then in Utena. Initially it wasn't the contact week, but I will try to visit you for maybe a day or maximum 2 days. Let's see. I would say it's not the same. Oh, wait a bit. I will maybe finalize